everybody, and welcome back. Today we're going to be talking about Unit 3, Lesson 4, which is derivatives of inverse functions. So today we're going to be learning how to use the chain rule along with the definition of an inverse function to find the derivative of an inverse function. And what I'd like to start with at the beginning here is just a brief review of what are inverse functions. So inverse functions are two functions that kind of undo each other, just like inverse operations undo each other. An example would be something like this. Let's say that f of x is equal to 2x and g of x is equal to 1/2 x. These functions would be inverses because they're doing opposite things to x. So for example, if you were to plug in the number 3 here, f of 3 would be equal to 6. And if you were to plug in the number 6 here, g of 6 would be equal to 3. So what they're doing is they're taking the outputs from one function, and if you plug that number into the other function, you get the previous input. So the inputs and outputs are switching. Now, the relationship, I should say one more thing. The notation for inverse functions is that we would say g of x here is the inverse of f of x. This little -1 is not an exponent. It means is the inverse of f. You could also say here that f of x is the inverse of g. They're inverses of each other. Okay, now what is the relationship? And this is going to be one of the most important things that we need to know about inverse functions between the inputs and the outputs. So here's the rule for the relationship between inputs and outputs of inverse functions. Let's say that we're going to make some tables that talk about two functions that are inverses of each other. And let's say that I know that when I plug in the number 2 here, I get 6. When I plug in the number 3 here, I get 9. When I plug in the number 4 here, I get 12. And when I plug in the number 5 here, I get 15. If I know that the next table is about the inverse, then what I know is that the inputs and outputs are going to switch here. So when I plug in the number 6, I'm going to get 2. When I plug in the number 9, I'm going to get 3. When I plug in the number 12, I would get 4. And when I plug in the number 15, I would get 5. This relationship right here, that the ordered pairs of inverse functions, you switch the x's and the y's, is the most important thing that you need to know about inverse functions in order to find those derivatives. Okay, instead of having a formula to find the derivative of an inverse function, which is what we have for a lot of things, right? Like we know that the derivative of sine is just cosine. It's just a rule. Instead of having a formula or a rule, we have a procedure that allows us to find these derivatives using the rules we already know. So instead of learning more rules, we're just going to follow this process and use the rules we already have. Think about this as being very similar to implicit differentiation. It's not a new thing. It's just a follow-up to what we already know. Step number 1 is going to be to write the problem without inverses. So let me show you what that means. If we know that g of x is the inverse of f, then we can essentially f both sides, which I know sounds not so great. And what that means is that we're going to have f of g of x on the left, but on the right, the f and the f inverse are opposites. They undo each other. So all we would have here is x. By doing that and kind of applying whatever function has the inverse to both sides, we get rid of inverses. We rewrite it without inverses. Then you're going to take the derivative using the chain rule. So when we take the derivative using the chain rule on both the left and the right, on the left side, we would start with the outside, leave the inside alone. So this is the inside. and then take the derivative of the inside. On the right side, the derivative of x is just 1. Then we're going to solve for our required derivative. In this problem, we wanted to know the derivative of g of x, and here we have g prime of x. So in order to isolate that, we're just going to divide by f prime of g of x. So g prime of x, which is what we wanted to know, would be equal to 1 over f prime of g of x. Finally, we're going to substitute our values. Oftentimes, you're going to have actual concrete numbers here. We're going to substitute our values, and we're going to calculate our final answer. So this process of rewrite, use the chain rule, solve, and then substitute is sort of without learning anything new, except for just reviewing what an inverse is and then using the rules we already know. It's a procedure we can follow that will allow us to find the derivative of an inverse function. Okay. Here's an example that is very typical of this type of question. Let f be the function defined by f of x is equal to x cubed plus 7x plus 2 if g of x is the inverse of f, and f of 1 is equal to 10. What is the value of g prime of 10? So let's start by just reading what we have here. We know the equation for f of x. We know that g is the inverse. We know that f of 1 is 10, and we want to find g prime of 10. Well, we know for step number 1 that g of x is equal to the inverse of f. So before I can find the derivative of g, the first thing I'm going to do is rewrite this without inverses. In other words, I'm going to apply f to both sides. So f of g of x will be equal to, and since f and f inverse undo each other, I should probably actually show this to help you visualize it. Since f and f inverse will undo each other, on the right side we just have x. Now we can find the derivative. So step number 2 is going to be to find the derivative using the chain rule. So chain rule says you start with the outside, f prime, leave the inside alone. In this case, that's just g of x, times the derivative of the inside, which would be g prime of x, equals the derivative of x, which is just 1. Next, we're going to solve for what we wanted to know. So step number 3 is solve for what you wanted to know, which was g prime. So g prime of x will be equal to 1 over f prime of g of x. There we go. Okay, now step number 4, which is to substitute and simplify, actually can end up being one of the harder steps. So let's give ourselves some space to think here. We want to find g prime of 10. So I'm going to go ahead and substitute the number 10 in here. I want to know g prime of 10, which is going to be 1 over f prime of g of 10. So again, I'm just substituting the number 10 in for all of the x's. Here's the problem. We don't have an equation for g of x. We also, therefore, cannot plug in the number 10 to find g of 10. So there's got to be something else in this problem that helps us figure out g of 10 without needing to know the equation. So how are we going to figure out g of 10? Well, let's go back to the instructions and see if there's anything we haven't used yet. We've used this when we wanted to go through this process. We used this to know to plug in the number 10. I also see the number 10 here. This is telling me that for f of x, we have the ordered pair 1, 10. Now, using what I know about inverses, I know that that means that for g of x, I have the ordered pair 10, 1, because these should switch if they're inverses. In other words, when I plug in the number 10, I should get 1, which means this can actually just be written as 1. So now my problem is 1 over f prime of 1. Okay, now I need to find f prime of 1. Well, I do have an equation for f, so that's lucky. So I'm going to go back up here to this equation for f. I'm going to find f prime, which is 3x squared plus 7. I'm going to plug in the number 1, which would be 3 plus 7, which is 10. And then that's my answer. So my answer would be 1 over 10. Now let's make sure we followed our 4 steps. Our steps were get rid of the inverses, take the derivative using chain rule, solve for what you wanted to know, substitute, and simplify. We did it. We got our derivative. We're done. Let's try problem number 2. So problem number 2 says, let's let f be a function defined here. We've got this long equation. G is going to be f inverse. F of 1 is 7. What is the value of g prime of 7? Just like before, step number 1 is going to be to get rid of the inverses. So my original equation here is g of x equals f inverse of x. In order to get rid of the inverses, I'm going to just apply f to both sides, which means I'm going to have f of g of x equals, and on the other side, the f and the f inverse cancel, so it's just x. Not cancel, but kind of undo each other because they're inverse operations, they're inverse functions. Step number 2 is find the derivative using chain rule. So chain rule says take the derivative of the outside, leave the inside alone, then multiply by the derivative of the inside. And on the other side of the equal sign, the derivative of x is just 1. Step number 3, solve for your desired derivative. I want to know g prime of 7, so I'm going to find g prime of x so that I have an equation to use. So g prime of x is equal to 1 over f prime of g of x. Now my 4th step here is going to be to substitute and simplify. So I want to know g prime of 7 means I'm going to plug in the number 7. So g prime of 7 equals 1 over f prime of g of 7. Now, just like before, I don't know g of 7 and I don't have an equation for g, but there is something in the instructions that can help me. This tells me that f has the point 1 comma 7, which means by the rules of inverses, g has the point 7 comma 1. So g of 7 must be equal to 1. That means that I have to figure out 1 over f prime of 1. Now, again, I have an equation for f. So I can go ahead and find the derivative. So f prime of x is equal to 21x squared plus, and I'm going to need to use chain rule for this part, I'm going to drop the 3, leave the natural log alone, squared, times the derivative of natural log would just be 1 over the stuff, which is just x. Now I'm going to substitute in the number 1, which means I have 21 plus 3 times the natural log of 1 squared times 1. The natural log of 1 is 0, so my answer is just 21, which means the final answer here would be that g prime of 7 is equal to 1 over 21. I'm actually going to skip problem number 3 because it is very similar to the ones that we already did. And let's go ahead and do problem number 4. So problem number 4 says if f of 4 is equal to 5, f prime of 4 is equal to 2/3, and g of x is equal to f of x, f inverse of x, find g prime of 5. Now, as soon as I see that there's an inverse in this problem, I know I'm going to follow kind of my inverse steps. So I'm going to start with the equation g of x is equal to f inverse of x. I'm going to apply the function f to both sides, which means on the left side I have f of g of x. And on the right side, I just have x. Then I'm going to take the derivative, and we've been through this process a few times now, so I think you can kind of predict what's going to happen. F prime, leave the inside alone, g of x. Then take the derivative of the inside, which is g prime of x, equals 1. Finally, we can just divide so that we can get g prime of x by itself. So g prime of x is equal to 1 over, and it's going to be f prime of g of x. Now, we want to figure out g prime of 5. So I'm going to go ahead and plug in the number 5 here and here, which means I have g prime of 5 is equal to 1 over f prime of g of 5. And let's see here. I don't know g of 5, but I do know that for the f function, I have the point 4 comma 5. I know that from right here, which means that for the g function, which is the inverse, I have the point 5 comma 4. So g of 5 must be 4, which means now I have 1 over f prime of 4. And I know f prime of 4 because, again, it's in the instructions. F prime of 4 is 2/3. So I have 1 over 2/3, which if you multiply by the reciprocal would just be 3 over 2. So my final answer here would be answer choice D. All right, I want to go ahead and do just 2 more problems where we're going to use a table of values. If you think back to when we first learned derivatives, we had a lot of problems like this where it was like, here's a table of values, use that to find the derivative. It's the same thing here. This is just another derivative kind of procedure that you need to know. So let's let g inverse be the inverse of g, and y is equal to g inverse of x, find y prime of -1. So let's start by getting rid of the inverses here. So y is equal to g inverse of x. I'm going to go ahead and g both sides, which means now I have g of y is equal to, the g's kind of undo each other on this side, so I just get x. Next, I'm going to take the derivative. So the derivative says start with the outside, leave the inside alone, which is y, and then times the derivative of the inside, which is going to be dy over dx, which is the same thing as y prime, just as a reminder, equals the derivative of x, which is just 1. Last but not least, I'm going to divide to get dy over dx by itself, because that's what I wanted to know. So dy over dx is equal to 1 over g prime of y. Now, this problem says plug in the number -1. The problem is that -1 is not the number that I can plug in here, because -1 is an x and y is a y. So I want to know, I'm going to replace the dy over dx with y prime just to make the notation consistent. I want to know y prime of -1 which means that on the y function, the -1 is the input. Now, if we're talking about g, on the g function, that makes -1 the output. Again, -1 is the input of y, but that means it's the output of g. So if I'm looking to plug a number into here, it has to be the input of g, not the output. I can figure that out. This row of the table tells me the output values of g. So when the output value of g is -1, the input value you know what? I think this was a typo. I think this should have been +1. Here we go. Let me just fix that really quick. When the output value is 1, the input value would have been -1. So -1, -1. There we go. That means that I'm going to do 1 over g prime of -1 which means that I'm now going to look at the bottom row of the table. G prime of -1 would be -1/5. So it would be 1 over g prime of -1 is -1/5, which simplifies to -5. Again, this is the input of y, which means it's the output of g. So to find the corresponding input, I need to go to the table, figure out where the output is 1, match it up to the input, and then that's the number I can plug into g, because I want to plug that into the g function. Last but not least, if g prime of x is the inverse of g, write an equation for the line that's tangent at x equals -3. Okay, so in this problem, I'm not going to go through this whole process again because it's the same problem. So I'm just going to start with, to write the equation of a tangent line, you need, there we go, equation for a tangent line, you need a point, you need a slope, and then you can write the equation of your tangent line. Now it tells me here that x is -3. So my point is going to have an x value of -3. Now here's the problem. -3 is the input of g inverse. So g inverse has -3 comma something, which means g would have something comma -3. Now, if you look at this table, there's no row in the table for g inverse. So what we have to do is find the -3 in the output row of g and match it up to the 4. So this would be 4 and this would be 4. That means that my missing y value is 4. To get my slope, I need to know the derivative of y, which we figured out a formula for up here. We know now that y prime is equal to 1 over g prime of y. Now we want to know y prime of -3. But we can't put -3 here because -3 is the input of y. That means it's the output of g. So just like these two ordered pairs helped us figure out the output value for the point, if I want to know the slope when the output of y, or the input of y is -3, then that means the output of g is -3, which means the input is 4. Now I'm going to go to the table. If I plug in the number 4, the derivative is -2. So I get 1 over -2. Now I've got my point, I've got my slope, I can write my tangent line, which is going to be y minus 4 equals -1/2 times x plus 3. Okay, that is it for today. Thank you so much, and I will see you soon for some practice.